Greetings and welcome to yet another installment of QuantSlob. This is 15 in our basic application series. This time around, we're going to close out our introduction to statistical hypothesis tests microseries. Like in the previous edition, part 3, a very simple agenda. This time around, we've been tossing around this term feature, so what's that all about? And with significance testing in mind, we're going to look briefly at statistical hypotheses. Much of the background here we've covered already on QuantSlob in the foundational series. The foundational series, highly recommended. It's already been playlisted for your edification and convenience. So we have a collection of observations, a sample or a data set, and a larger population from which our sample was somehow realized. A feature or value that is constant across our population we call a parameter. From our sample now, or data set, we may calculate a sample statistic. Our sample statistic will be calculated from our sample in such a way that it may serve as an estimator for the population parameter. So to offer a couple very simple examples of this, we may use a sample average of some quantitative attribute to learn about the average of this attribute within the larger population from which the sample was realized. We may analogously use the sample proportion of a category to learn about the proportion of this category within the larger population. By the way, in the context of this sort of relationship between our estimator and parameter, our parameter is sometimes called an estimand here. Soon upcoming here in this basic application series, we will be detailing the tactics of executing statistical significance tests. We're going to be working through several examples. Here, to close out this introductory microseries, we're going to sketch out the look and feel of statistical significance test hypotheses. So we have two hypotheses. Both hypotheses should always be hard and fast mathematical statements about our parameter of interest. The null hypothesis, H null, is a mathematical statement about our parameter that represents the status quo, the default, or if you prefer the conventional wisdom, or it could be something that is simply passive or neutral about our parameter. Let's move it along. Nothing to see here. Don't trip potato chip. Sometimes on the streets, we also like to call our null hypothesis the you ain't got nothing coming hypothesis. I just made that up, but it actually sort of works in a way. Okay, so the null hypothesis is a mathematical statement about our population parameter. So what kind of statement? For a single valued parameter, say, for example, if we're looking at the average of some quantitative attribute of our elements across our population, we often like to see strict equality in our null hypothesis. More broadly speaking, and in much more advanced terms, the null statement often defines a boundary or a partition here in our so-called parameter space, and we'll talk more about this later. It's more advanced. It's a more advanced idea here. The other hypothesis we call our alternate hypothesis, or HA, or H sub A. As the name suggests, alternate is a statement that is in opposition to the null hypothesis. In some circles, the alternate hypothesis is aptly called the research hypothesis. While we may think of our null hypothesis as reflecting the status quo or norm about a parameter, our alternate hypothesis will reflect a space of parameter values that is in opposition to the null or status quo. Which region of our parameter space? Well, whatever is relevant or of particular interest with whatever research we happen to be conducting or whatever sort of investigation. For example, suppose we're studying the population of living, breathing narwhals, and we're interested in learning about the proportion that are psychedelic and code Haskell. Well, I think we'd all be rather astonished if the proportion of narwhals that are psychedelic and can write any sort of computer code, let alone Haskell, were any number other than exactly 0. By the way, we really don't need a statistical test here, because if we observe just one living, breathing, psychedelic Haskell coding narwhal, we can reject the null hypothesis with perfect certainty. The null in this particular case is, so they say, empirically falsifiable, so that should keep all of our fun-loving positivist friends happy. And if you do find a living, breathing psychedelic narwhal that codes Haskell, you, my friend, are definitely getting published. And you can just list QuantSlob as a co-author. I got no problem with that. Immediately upcoming in our basic application series, we're going to look at sampling and revisit distributions, and we're going to resume with a number of installments dedicated to working through statistical hypothesis tests. And this time around, that's going to do it. Thank you very much for tuning in. Don't forget to stay tuned for more QuantSlob.